Hi there, so we're over at STFC in Daresbury. Very excited today because it's the INST factory acceptance test, the instantly networkable smart triaging system factory acceptance test. So we've been working on this project now with the European Space Agency, the ESA, for quite some time, and we've been developing a technology, and the challenge that was brought to us was that in the awful kind of mass casualty incidents that we see, what happens during those incidents is that the emergency responders go along and they're tasked with dealing with whatever's happening on the ground, and that's got to be their primary focus. But as you can imagine, it's a horrendous, chaotic situation during these events. Very difficult to manage what's going on. And one of the things they were telling us was that you have casualties, you have different levels of injury, from sort of walking wounded to worse. And the first responders, they're dealing with shutting down the incident itself, so they have to be focused on this. And their primary focus can't be initially on the casualties. And this is difficult. And what we need is a way to kind of help to support them, particularly to locate casualties and to monitor where they are and if they're moving around, and identify them, because you can misidentify, you can multiple identify casualties, and sometimes you can miss them. These are all things that have happened in events. So we were asked if we could, if I can show you what we've got here, we were asked if we could come up with some technology to place onto casualties during incidents and locate them, work out where they are, so that we can track them and we can make sure that they get the help they need, and we can get them to safety. And that's what we've been working on, that's what we've been trying to do here. That's the INST project. So, as I say, we've been working with the European Space Agency because, again, what we're trying to do here is to develop a rapidly deployable ad hoc networking system, so that all of these positions can be communicated in a resilient way. And then that needs to get out to the cloud to be dealt with somehow, to operational commanders, boots on the ground. And to do that, one of the best options we felt was to use a space backhaul. And what you can see here, this unit here is a micro base station that we're using. That is currently communicating with a satellite constellation, and that's giving us, quite amazingly really, a level of internet connectivity. So that's our uplink from anywhere, effectively, to be able to deploy communications capability into wherever an event might be occurring. So we have that up, and then here, that's connected. You can see the next bit. This is our prototype gateway hardware. We have developed and manufactured this, and essentially it's, for those who are interested, it's an NXP IMX series processor running an embedded Linux operating system, and that's connected up to the cloud through our partner company, Foundries.io, who provide remote management and connectivity and update capability to these boards. So that gets us connectivity through the cloud, the internet to the board. And on the board here, there are a number of communications technologies. This has been designed to be very, very flexible in terms of communications transceivers modules that we can connect to it, so that it's future safe, and we can essentially plug in any connectivity that we think would be useful. So for now, this has the obvious connectivity options of Wi-Fi. We are power over Ethernet, but also we have LoRa connectivity to communicate with our ad hoc network locally. We also have an 802.15.4 radio capability to use thread mesh networking to devices in the field. And we can change this around in future if we think that there are other radio technologies that might be useful to us. Similarly, as we're here at STFC, we've been working closely with the team here on the 5G rollout. They have a private 5G cell that we've been looking at, we're testing with them, and we can put a 5G module into this device so that we have 5G backhaul. So what I'm trying to say is that we have multiple redundant backhauls available to us for resilient communications in a wide variety of difficult situations where we need to deploy fast. As you can see, we are doing our prototype testing in a minute, but you can imagine that this will be boxed up into the finished product, and that will be the next stage that we're working towards after this day of day 2 days of FAT testing. So we go over to a tag. You can see a tag here, wearable. That's picking up location position through a constellation of GNSS satellites. And it's periodically transmitting that location information over the radio network, where it goes through our gateway, up the satellite uplink, and then through the servers into the cloud, where it's then represented on a portal that's been developed by our partner company, Mvine, who have a lot of experience in this kind of activity. And they've developed, I don't know if we can see that here, but they've developed a portal which shows the locations of the tags in real time and the triage status of the individual who has been positioned with the tag. So for example, there are standard identifiers used by the emergency services for triaging casualties, P1 through 4, and we represent those now visually, graphically, and that can be accessed by those who need to control the operation, either on laptop computers or more likely mobile devices, pads, these kinds of things that you might see in a command center on site during an incident. So we're about to go through our set of tests. Wish us luck, and thank you very much.